Hi, my name is Shinji from IBM IoT Support. In this video, I will demonstrate the process you need to know to convert dishwasher sample to be IoT compatible. You are seeing now how I control dishwasher from web simulating mobile phone, and you know how to do it at the end of this video. This video is first. Adjust the video speed slower if repeating my steps. I will pause at key point and provide explanation. The purpose of this video is to help you understand the whole process in just 9 minutes. Now, let's first deploy IoT Workbench service in Bluemix. IoT Workbench is listed as an experimental service, located under Experiments section in Service Catalog. Double-click on the icon, name the service, and deploy it. Now, name the solution. Solution is a specification to describe how your device and services interact and connected together. Now, time to design. In this design, dishwasher sample, which is a device, will communicate with mobile via IoT Foundation. The element grouped under executable entity affect the code generated by Workbench. The other elements, such as hosting or Blue Cloud I drew, is only for notation. Moving to interaction diagrams. Interaction diagrams are just informative. That means they do not directly affect code generation. But clicking autofill on a connector will create messages defined over that connector, which will affect code generation. Show you shortly. Before testing with real dishwasher sample, I want to test MQTT transmission with simulated devices. I am adding two attributes and will enter code that will be executed when MQTT packet received to manipulate these values. Now, we define message on the MQTT connector. This part of modification is not for simulation devices, but actual device, meaning dishwasher. Messages you defined here are later imported into Rhapsody. Stop the video and see how these messages appear in Rhapsody. Next, we define messages on the other side of connector, that is HTTP. Your mobile client or web page interact with your application by calling REST calls, such as GET or POST you define on that connector. I show you how it works shortly. It's time to deploy the application to Bluemix. We want our application to be Node-RED. So uncheck this option if you want to generate in Node.js. Deploying the application to Bluemix could take 10 minutes or longer. Once the deployment finishes, you see Node-RED, IoT Foundation, Cloud and DB, 3 services generated in your project. We are going to connect IoT Foundation and Workbench in the next step. To connect IoT Foundation and Workbench, I need to generate API key to secure transaction between the two services. You are watching how I generate API key and fill up the form. Once form is filled, press OK and save change. You are watching the process to add simulated devices from Workbench, which will appear on IoT Foundation as registered devices. This step is necessary before running a simulation. Not all changes you made on diagram affect code generation. If Workbench determines Node-RED doesn't have to be updated, you will be notified after pressing Deliver button. In this case, change is delivered. Let's navigate to the Node-RED to see the code generated. IoT is about connecting devices and services together. You see here the aspect of it. Blue node represents one or more devices registered in IoT Foundation. Remember, we have 2 simulated devices registered. Yellow node represents a HTTP client, in this case mobile. Those nodes are automatically generated by Workbench. I'm copying device ID from one of simulated device and set the value on blue nodes, so only MQTT packets are sent to a particular device. The green node is used to output the data coming through for debugging purpose. Now, all the hard work was done. We will start a simulation to see how MQTT packet sent from mobile via HTTP is received by one of the simulated devices and see how it changes the internal attributes defined earlier. Device ID sent from mobile is not processed in Node-RED. Do so if needed. The simulation results confirm everything is good. Now I'm going to check with dishwasher. Let's enable dishwasher IoT enabled. First, we will import the solution into Rhapsody. Start up the Rhapsody. I'm going to copy the existing dishwasher and name it something else, say connected dishwasher. Make sure you install MQTT Foundation profile in your Rhapsody. Should be version 8.1.3 or higher. If you don't see the option to import the solution. You will find a link to download the profile in my blog entry. Read the attached README for installation. This part is very important. I use inheritance to empower the existing dishwasher class to be able to consume MQTT packet. Those operations tagged with MQTT send or MQTT receive is used to communicate IoT Foundation I define in Workbench. Before injecting those operations into the state chart, I need to specify device ID for my dishwasher instance and get it registered with IoT Foundation. I also need to generate API key for secure transaction. You will see next. Go to IoT Foundation and open tab that show all registered devices. You will see a button to add a device. Click on it. Follow the wizard and generate API key. Store the generated token to auth token attribute. Now it's completed. Finally, I'm going to wire up the existing state chart with using MQTT method. MQTT receive operation you use to trigger a transition. MQTT send operation you use to send information to IoT Foundation. Design Node-RED to connect your device to external systems. Now I update my Node-RED to replace old value with the device ID for my dishwasher. To commit a change, I need to redeploy Node-RED. Forget about error shown on the debug window. Will be fixed in future. Change initial instance from dishwasher to connected dishwasher. At last, you need to change the visibility of setup method defined within dishwasher class, either to protect or public, to solve compilation error. That's it. Let's start animation and see how transition occurs inside connected dishwasher. As it receives start, stop, change mode signal from mobile client. Each time state change in the red enclosed area, a MQTT packet is sent to IoT Foundation and flow into Node-RED. Earlier in the video, I defined switch mode method on the MQTT connector to take only one argument. If you want to pass more than one argument, you need to add two changes to your specification. Otherwise, whatever you pass will be ignored and the expected transition doesn't occur. What you see on the screen is just one example. Here is a change I made to pass device ID in addition to mode. Note that passing device ID to dishwasher makes no much sense. It's purely done for demo purpose. You can also check the transaction history. Visit Watson IoT homepage and check IBM Watson IoT platform demo, which I refer as IoT Foundation during the video. Explore the range of cognitive capability that platform offers, which you can induce into your devices. Thank you for watching.